Hi, everyone. Thank you so much for joining us. We're at the top of the hour now, so I'm going to kick us off. But before we get started and get into the content, I have just a few housekeeping items to cover. First off, hi, I'm Mariah Hauk. I'm the Marketing Program Specialist here at Planet, and I'm here to just make sure everything on the back end runs as smoothly as possible. So if you could take a moment and locate your control panel, it's going to be on the right-hand side of your screen there. That's where you can access your support site. If you're having technical issues, you can read the chat and ask us any questions that come up during the webinar. So let's test that out right now. If you could click on that question icon and in the chat, share maybe where you're joining us from today. I am in California and it's still pretty sunny here, but starting to get a little chilly. Or maybe just tell me what you're gonna have for dinner, really anything, just so I know that that chat function is working for you. That'd be really great. And then while we test that out, let me just share a little bit about this webinar. So today we're going to cover CropBiomass. This product combines optical and radar satellite observations that penetrate the cloud cover to provide daily 10-meter data over agricultural fields. So we're going to try and keep this to about 30 minutes today. So pretty short and sweet, but we will save some time for questions at the end. So feel free to drop in your questions throughout the presentation and we'll get to as many as we can. If we don't get to your question, please always feel free to reach out to your customer success manager if you have one. If you're not a Planet customer, you can also use our general contact form. I'll drop a link to it in the chat, and it's also on our website, that big blue button in the right-hand corner. Before I do that, let me just check the chat and make sure it's all working for you guys. Okay, Levi from South Dakota, hello. Nick, also a Californian. Someone coming all the way from South Africa, New York. Great, I don't see any dinner recommendations though, but I'll keep an eye out for that. And I think that's about it. I just want to remind you that this is being recorded, so don't worry about taking notes or trying to remember everything. This will be shared via email within the next couple of days. We'll also send you links to any resources or emails that we share. So with that, let's dive in. I'm going to pass the mic over to today's host. Take it away.
Hello, how are you? First, thank you so much for being here. Second, I'm also in California and in the Bay Area, and we just got an earthquake emergency alert. So if you see that things starts to shake a little bit, that's the reason. Everything will be fine. So we'll keep moving on the webinar. So my name is Ariel Zaiban. I'm a product manager here at Planet, working in agriculture. That's my email in case you want to follow up. I know that my last name is a little hard, but yeah, happy to talk about this anytime. So feel free to reach out. So just to give some context about Planet, we are known in general as a satellite company. So we have our monitoring solutions here on the left, our PlanetScope constellation that images the world almost every day at the 3.7 meter resolution. We also have our tasking satellites. It's called SkySat. We have a 50 centimeter resolution there, but maybe the less well-known products and solutions from Planet are the ones on the right side. So we have planetary variables. That is a family of products that basically are very easy to use and measure different variables like land surface temperature, like saltwater content. And today we'll talk about CropBiomass. We also have products that measure different aspects of forest, like biomass and carbon. And the last one is the platform. So we recently announced the acquisition of Sentinel Hub, which is a platform that enables the analysis of remote sensing data basically on a web application that is very complete. If we have time, I'll do a demo, a very short demo on this product, on this platform. And again, always happy to answer questions and go through this in more detail. So also as an introduction, I decided to put these 4 pictures. This is all agriculture. So of course that's in common. We have corn being harvested in China. In the top right, we have lettuce grown in the Salinas Valley, about an hour and a half south of where I am right now. Then we have sugarcane in Sao Paulo, in Brazil, and we have also wheat in the UK. So what these images have in common, this is more a rhetoric question because I will give you the answer, rhetorical question. There are clouds in the sky, right? So this is not uncommon for agriculture and when we use satellites. 2/3 of Earth's surface is typically covered by clouds. This is not a claim that I am making, it's just reality, and that's the reference for the paper that actually is using MODIS data to measure this. So clouds, in particular, when we use optical data, are abstracting the ability for, are limiting our ability to understand what's happening behind the cloud, right? This is here in the background. I have another satellite image from the state of Mato Grosso in Brazil in January 20 this year. I picked January 20 because soybeans in Mato Grosso, which is the largest state where soybeans are grown in the world, are typically planted between September and November, December. So January is a key month, and January 20 to like within that month to understand the status of the crop. And it's very typical to have persistent cloud cover from December 15 to January 15, or all the way to the end of January in this area. So we cannot rely only on optical data to understand what's happening in these fields. I will also give an example in northeastern Mexico for the case of a sorghum field. Sorghum is a very important cereal crop. So just to give you a context on sorghum, it's planted in February, March. Around April, there are all the operations around weeding and herbicide applications. If needed in April, you apply an insecticide, and then this crop is harvested later during the year. So if I plot an NDVI curve of a sorghum field in northeastern Mexico, in particular the one that will follow throughout the slides, will look like this. So we have the planting. In this case, we have the harvest that is a little bit earlier. And what you will notice is that there is a big gap here, right? Like each point is one observation. And in this case, we're looking at NDVI, which is an index that I assume you are familiar with, that is only based on optical data, that looks at the difference between the near infrared and the red bands. So basically, in this area, we have a big gap that is about a month. So it's around mid-April to mid-May, where we don't have any optical images, so we don't know what's happening in the field. And this is where we, by the way, I didn't say it, I'm an agronomist, and we make a lot of decisions around crop management during this particular period of crop growth. So we need to know what's going on. If we rely only on NDVI, we have one image in this case on April 10. This is for last year, and this is how this field looked like. And then the next one would be in May 14. So you see how there are big differences in what's like the status of the crop and what's happening in this field. And this uncertainty is not only for a farmer or for an agronomist, but it's for many people that are monitoring this field. So this is not only relevant for management, but also for monitoring, right? We have government agencies that, in the case of Mexico, in particular for small scale farmers, is very important in providing warranties for insurance, also for insurance companies, for the people providing credit, for input manufacturers, retailers, equipment manufacturers, and also from the people buying or sourcing ingredients from this field. So there are a lot of people interested in knowing what's going on in the field, but for more than a month, there is nothing that you can, like, there are no news if you rely only on optical data. So I show you an example on northeastern Mexico. So I hope you can see my mouse here. So we are talking about this area. This is a paper that now has 6 years, but basically what they did was looking at the number of months where you have what they define as a persistent cloud cover period. In this case, is 8 consecutive days where you have clouds every day, so you can't get any cloud-free optical data. And what I'm trying to say here, based on data, is that this is not only northeastern Mexico, right? Like the usual suspects, we have tropical areas, Central America, Europe, India, Southeast Asia, some parts of Brazil, in particular, like the areas that we talk about, like Mato Grosso, Mato Grosso do Sul, also the Southeast. So we have a lot of areas in the world that are very important for agricultural production, where for a number of months, we have these long periods with persistent cloud cover. Okay, so the challenge is then, how can we deliver data on these areas, right? Luckily, we have satellites that can penetrate the cloud cover. In particular, the ones that we are using for this product are called SAR, or synthetic aperture radar satellites. They can penetrate the cloud cover, so we can measure the status of the crop at the field level. But unfortunately, there are some spatial challenges, right? Like you can see here, sorry for that. This is a raster that is directly obtained from SAR data, and you see all the speckles, right? Like also we have different orbits and observation angles. So this data by itself is hard to use, and also spatially doesn't give you a lot of information about what area of the field might be doing better or worse. In particular, with SAR data, something that we can do is the same as with NDVI. I talk about different bands that you can combine. With data from active microwave satellites, what we can do is also do some math with all the different polarizations. And there is one index called cross ratio that is very well correlated with the vegetation water content. So what I'm saying here, that is the important part beyond all the graphs showing that relationship, is that this is for only one paper for some crops, is that what we are measuring here with radar is the water content of the vegetation, is not the reflectance from the crop. That is what we measure with optical data. So basically, to come up with a product that can deliver data on cloudy areas, we are combining Sentinel-1 radar with Sentinel-2 optical data. The Sentinel-1 radar can penetrate the cloud cover, and basically by combining both, we can deliver a daily product at a 10-meter resolution that we can trust its spatial distribution, but also deliver data, as I mentioned, under cloud cover. So just to reinforce what I've been saying, we combine both and we deliver what we call and consider an analysis-ready data product. This product is very easy to use, so we deliver a GeoTIFF every day. And that GeoTIFF has only one band, that is per pixel has a value from 0 to 1, that is this CropBiomass, which is an index that we calculate. And this is a time series that is full because it's daily, that starts on January, so the first day of January 2019. So going back to our example in Mexico, so this is another graph showing, but in this case, I'm showing the CropBiomass values. And remember, in gray here, we have this period for which we have no Sentinel-2 observations. So here in the black dots represent the Sentinel-2 cloud-free images for that field. I pick one day within that that period, but we deliver data every day within any period. And you can see the raster that represents, again, from 0 to 1, the values for the crop biomass for that particular field. So this is what our customers get every day. It's a new raster. In particular, I pick April 20 because it's my birthday. So next year, April 20, it's easy to remember. 420, you have my email now. You send me a note. You can send me a gift too. I'm open. Okay, I'll keep moving here. So one thing is that it's a limitation for this product is that Sentinel-1 is composed originally by two different satellites, Sentinel-1A and 1B. Unfortunately, at the end of around December 2021, Sentinel-1B basically stopped working. So right now we only have Sentinel-1A, meaning that we have limited coverage of this product. So we don't have Sentinel-1 coverage everywhere. So if you see here, the gray areas are the ones for which we cannot deliver the product right now. We are expecting Sentinel-1C to be launched next year and to recover the daily coverage there. We don't have a lot of time, so that's why I'm going fast. I'll be also happy to talk more, and also I think the Q&A might be more interesting. But if you remember, I was telling you that we combine two different indices. We combine Sentinel-1 cross ratio, in this case in red, and then in purple you have the Sentinel-2 NDVI. So what we can see here, this is for a field in Panama. What you can see here is first how at the beginning of the crop growth, both curves move very closely together because like the water content and the nitrogen in the plant, which is like it's very well correlated with so basic not in the plant but overall, like the reflectance from the chlorophyll pigments, they move very close together when there are images. For example, in this case, if you can see my mouse, like in this case there are no NDVI images here, so but the Sentinel-1 data picks up the growth of the crop earlier because we can do that. So in green, what you see is the curve for the values of our product, of the CropBiomass, that here it says bioentropy because that was the name that used to have. So at the beginning of the crop growth, they move together. But then what we see in general in grain crops, in annual crops, is that after flowering, the crop, when the grain is harvested, you have the senescence period, and during senescence, the crop basically dries and loses its green color. So the NDVI drops, but the crop biomass values keep going, so they stay because the water content of the vegetation is still high. So that's why we see these differences between the NDVI and the crop biomass value. That's also why we see a lot of potential in also combining both signals from the signal from the crop biomass with the signal from NDVI, for example, or any other optical vegetation index. Sorry for that. To do things like identifying events such as harvest, mowing, but also to identify different stages of crop phenology. So this is an example. I don't want people for you to get into all the details in this graph, but this is also another example of that differences in the signal, in the nature of the signal. So here, this is the canola or rapeseed, as is known in Europe. So canola has a yellow flower, and the yellow flowers reflect red, meaning that the NDVI drops when the flowers during flowering, but the crop is still there. So here we see clearly, like we have in green the PlanetScope data, and in blue the Sentinel-2 data. So the differences in the values are mostly because one is surface reflectance and the other one is top of atmosphere. But the important part for me here is this one, right? If this is flowering, you see the peak in biomass, and after flowering, the NDVI drops suddenly, but the crop is still there. And how do I know this? Because the crop biomass is still there, right? But then after harvest, that's when the values actually drop. So these are basically some images of the flowers and the NDVI at that point. So this is just more details on this example. Something that we are also continuously doing as a team is working on field validation. We know and we acknowledge that this is a new product. People are very used to using NDVI, but this is new. And in general, Sentinel-1 data has been very difficult to use. So we are making it very easy to use, but also we need to validate and show how useful this data can be in the field. So we work with different partners, mostly in academia, but also in the private sector, to collect field data and to compare that field data with our values that we measure from space. This is one example that I'm showing you. We are doing different experiences like this. And if you are interested in collaborating with us, reach out. I'm happy to talk about that because we are always looking for partners to do this. So in this case, this is in Nebraska. These are corn and soybean fields. Some are irrigated and some are rain-fed. And basically, they measure above ground biomass and also yield. So what I'm going to show you is first, in this research station, when you follow, so here in the black curve is the crop biomass. It's the data that we measure from space. And then here in green, you have the total fresh biomass of the crop, and you see how both curves basically follow each other. The other curves, what they represent are the different components of that biomass, right? Like the leaf, the stem, and the grains that they appear later. These for corn fields. We also have very good correlations in this with this data, both in combining both irrigated and rain-fed corn fields, and you can look at the above ground fresh biomass and our like the values of our values, basically the values of the crop biomass product. And we also evaluated basically a correlation between the yield, so the grain harvested, and the crop biomass. In this case, the crop biomass, it shows as one value, but it's actually the average within a given period of time that correlates well. We think that getting a 0.7 R-square for yield, for the ones who are familiar with yield forecasting, is a very good correlation. But still, it's not about the number, it's more about showing the value and showing how we can actually trace the status of the crop throughout the season. As I mentioned, we are working with different partners in different crops, in validating, so let us know if you're interested. We keep improving this product year after year. So right now we are in version 3 that was released in February. We work a lot in cleaning the signal, so removing the outliers, also having a higher sensitivity to events like harvest, like mowing, to actually show the drop in biomass. We added metadata fields, so you know what was the latest image from both Sentinel-1 and Sentinel-2 that was used to generate the daily raster. And also, we are now integrated to Planet's API. So a little context about this. This product is actually part of the acquisition of Planet of the company called Bandersat from the Netherlands. So it took some time to actually integrate this family of products, the planetary variables, into our Planet ecosystem. And now our users are getting the data through Planet's API. We are right now working on version 4. Version 4 will also present significant improvements. The 3 that I think are worth sharing. One is that we'll be incorporating PlanetScope as a source of optical data. So we'll have a significant increase in the number of direct optical observations. We are also working having a higher contribution of Sentinel-1 spatial data, because if you have a very long period of cloud cover, then we want to rely more on Sentinel-1 to get a more updated raster, the spatial distribution of the data. So, and also that will give us a better ability to detect events such as harvest, herbicide burn down, and mowing, among others. So here I'm showing you one example. This is a field in Cordoba in Argentina, where I'm originally from, that they made, the agronomist made a seed prescription with Messi, the soccer player who scored 2 goals yesterday, face, and I don't know if you can see his face here. We have actually another example. So this is also to show the spatial distribution of our product. So what I want to highlight here is that if right now we are relying only on Sentinel-2 as an optical source of optical data, we'll be not replacing but adding PlanetScope. And for the case of the field in Mexico, you see how that results in a much higher number of direct optical observations for this particular field, right? Which also doesn't mean that but also acknowledging that during periods of persistent cloud cover, such as this one that I was stressing in April 2022, even with PlanetScope, you don't get a cloud-free optical image during that period. So, sorry, I'm not doing great. So if you look at, so I think we have a couple minutes, but if not, I can do it during a Q&A. But now we have this platform called Sentinel Hub, and our team uploaded data for the entire country of Slovenia. I'm not going to do the demo right now, actually, because we don't have time. Happy to do it if you are interested. Let me know, and I can do that for you. But basically, what I want to show here is that the Sentinel Hub platform gives us the ability to actually conduct a lot of this analysis on the platform. For example, we have all the 640,000 fields for the country of Slovenia, and you can just like get a field, mark a field, and get the time series, for example, in this case, for the last 2 years for that field, the full time series, and you can export the CSV and get all the data. It's very easy to use. So I wanted to also make that comment because that's where we see the future of Planet in a lot of ways. For some customers, we already did a lot in making a product easy to use, but we want to make it even easier to use in the future. So with that, I will conclude the presentation. I'm happy to answer any questions that you might have.
Thanks, Ariel. That was really a great overview. Thanks for sharing a bit about Planet and this CropBiomass product. And like you might have, but the chat is blowing up with questions. So I'm going to try to get to a few of them now. And then, of course, any that we don't get to, feel free to reach out to your customer success manager or drop those in our Contact Us page. But I'm going to dive into it now. We got this question a few times. One of them was from Andrew. How do you deliver daily data given that Sentinel-1 and Sentinel-2 is not daily?
Excellent question. So what we do, and I remember for myself, next time I need to explain that better. So just so people are aware, Sentinel-2, depending on the latitude, the frequency is between 3 to 5 days, the frequency of revisit. And Sentinel-1, depending on the location, is from 2 to 3 days in Europe to 12 days in some areas. So what we do is we calculate a rolling average based on the latest observations, and we change the weights as they progress, giving a higher weight to the latest observations. It's kind of like a smoothing function that also allows us to deliver data every day. That being said, the smoothing function is not fixed in the sense that if we identify using other parameters from Sentinel-1 data that there was, for example, a harvest, we reduce that smoothing function. So actually we show the sudden drop in biomass. So a little more complex, but the short answer is rolling average, and the rest is the longest explanation.
Right. Thanks for going over that again. This one is from Michael, and I think I saw it mentioned in another question here. There's some similarities, it looks like, with Planet Fusion. So how does this product compare to the Planet Fusion product?
Good question. So Planet Fusion, there are a couple of big differences. One big difference is that Planet Fusion, what you get is RGB and NDVI images, right? And here what you get is a CropBiomass that is a different index that is based on Sentinel-1 data. So that's the main difference. The other difference is that the way it is consumed and delivered. So this is a field-based product. CropBiomass is a field-based product. So as a customer, you subscribe your field polygons and you get daily rasters delivered with the latency like every day. And today you get the data from yesterday, right? So that's how it works. Fusion is different because you get a big tile that is 24 by 24 kilometers, so 576 square kilometers. So it's not, you don't have an ability to clip in Fusion. Like you can clip, but you need to get the entire tile.
Great. Sorry, I'm just monitoring here. Here's another one from Ram. Is there a minimum farm or ranch size for the insights you provide to be effective? So minimum AOI.
That's an excellent question. So we started with 1 hectare, and we have excellent results. When we did these tests in Slovenia and in other areas where field sizes were small, even like a tenth of that, we are allowing now customers to draw polygons as small as a tenth of a hectare. And so far, we've seen very good results. So that's where we are right now.
It's great. Yeah. Looks like we're improving with each iteration. Let's see, we're right at time now, and I know there's a ton more questions. So as a reminder, Customer Success Manager, or feel free to reach out on our Contact Us page. We might also be able to round up these questions and post them on Planet University. So we'll look into that, since I know we've got a ton more questions that we weren't able to get to. And in the interest of time, I just want to share a few more things before I let you go. Ariel, can we go to the next slide, please? If you guys are ready to get started with CropBiomass, you can reach out to Adela. She's going to be your Planet representative, and her email is in the chat. So feel free to reach out to her, and she'll get you in contact with the right person. As a reminder, all of these resources that we mentioned, and the links and the emails, will all be in an email coming to you soon. So keep an eye out for that with the recording. I wanted to thank Ariel for his great presentation. I hope you feel better very soon. And thank you all for joining us. Really appreciate it. If you have maybe 30 seconds right here at the end, a survey is going to pop up when I close out the webinar. We just want to hear your feedback. How do we do, and what else do you want to see from us? What else do you want to know? Let us know if you have any ideas for future webinars. We want to give you what you're looking for. So with that, I'm going to close it out. Thank you again. We'll see you around here soon.
Thank you.